Hi students, welcome back. Today we are going to talk about the distributive property. This is a property that is going to come in so handy as our problems start to get more and more complicated. So this is a property that's really important. Now I'm going to start off by showing you how distributive property compares to order of operations. It is just another way to solve something that'll give us the same answer, and then we'll talk about why we would do that. So over here, you'll see I have the same exact problem written down twice. That's because I'm going to solve the first problem with order of operations, which is what we've been doing. And then I'm going to show you the second problem using distributive property, and we're going to see that we get the same answer either way. So order of operations tells me the first thing I would do would be add inside my parentheses. So 5 plus 2 is 7. And so the first thing I would do is get that and then continue. And then 6 times 7 is 42. And I get my answer. Distributive property is just another way to solve this problem. So distributive property is actually going to have me take this 6, and instead of doing the addition first, I'm going to distribute the 6 to the 5. So I'm going to multiply 6 times 5, and then I'm going to distribute the 6 to the 2, and I'm going to multiply 6 times 2, and I'm going to do the addition second. So 6 times 5 is 30. 6 times 2 is 12, and 30 plus 12 is 42. So you can see our answer for both problems is the same. So both strategies work. Now, I'm sure there's a bunch of you going, oh, but that one was shorter, it was quicker. I always want the quickest way. Yes, totally agree. However, we're going to see that distributive property is really important when we start to think algebraically. And we know, we're getting into those algebraic works. So this is going to be really important. So distributive property comes in handy as soon as we see variables. Because if I'm looking at my problem, and I think, okay, first thing I always do is inside the parentheses. Some of you right away are going, oh, we just looked at combining like terms the other day, and I know that, I'm going to have a problem, right? Because 3x and 5 are not like terms. So that means I can't add them together. So I'm stuck. Oh no, I can't do the problem. Well, no, that's not true. We can do the problem. We just have to solve it in a different but equally correct way. And that's using distributive property. So distributive property is really important in algebra. So we're going to distribute that 5 to the 3x. So 5 times 3x. We're going to distribute that 5 to the 5, so 5 times 5, and this is where it's important to pay attention. We were adding, so we need to keep adding. We're going to distribute the 5 to the x. And again, really important, we were subtracting, so we're still subtracting. Now, this is where we need to think. This means I have 3x happening 5 times. So I'm going to put this off to the side, although you don't need to write out this step. But that basically means I have 3x, 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 right? And I'm adding them, pushing them all together into one single pile. So how many x's do I have? Well, the shortcut is just to multiply 5 times 3. So 5 times 3 is 15. So I have 15x. Okay, bring down my addition sign. 5 times 5, 25. Bring down my subtraction sign. 5 times x. Remember, that just means I have x happening 5 times. So I have 5 x's. Now we're going back to what we just talked about the other day, which was combining our like terms. So 15x and negative 5x. Remember how we talked about really focusing on the negative in front of the term? I'm going to combine those together. So 15 minus 5, 10x plus 25. Now I'm done. I have to stop there because these are not like terms. So when we're simplifying, our answers are often expressions. And for some of us, that's a little uncomfortable. That's kind of new. That's okay. You'll get used to it because that happens a lot. So we're done. That's our answer. All right, let's try our next example. Again, we're going to distribute the 7 to the 6x. So this becomes 7 times 6x. Then we have addition. Then we're going to distribute the 7 to the 9. So 7 times 9. So remember, 7 times 6, 42x. And remember what I showed you here. It's like 6x plus 6x plus 6x plus 6x 7 times. Remember, multiplication is just a quick way to do addition. And then 7 times 9 is 63. We're done. That's our answer. We cannot go any further because 42x has a variable. 63 is a constant. Those are not like terms, so we cannot combine them. Okay, so we're going to do some practice problems with simplifying expressions.